Alrighty here. Let's look at number 2. Solve the system classified as independent, consistent, dependent, consistent, or dependent, inconsistent. I'm going to do this with elimination. I'll probably do anything on this page with elimination just because it's the more important skill. So I'm multiplying the bottom equation by a -2 so that when I add down, the x's disappear. So -2 times x is -2x, -2 times 5 is -10y, and -2 times 13 is -26. And I'm going to have no x. I'm going to have a -8y when I add, and 10 plus a -26 is -16. I'm going to divide by the -8, and I'm going to have a y value of 2. And you could probably already go ahead and classify the system, but it does say solve. So if I have y, I can just turn around and plug that joker right back in. 2x plus 2 times a y is encountered, 2 is 10. This is 4. 10 minus 4 is 6, so 2x is 6 and x is 3. So what we have is we have two lines, because those are lines that are intersecting at a point. And because they are intersecting at a point, I can call it independent. I've got this backwards. Consistent, independent. I'm not going to rewrite that, but consistent, independent. Like, I get the elimination method. I remember being a kid and a lot of my friends didn't, and it boiled down to arithmetic and multiplication and division. All right, more solving and classifying. I just don't want to do it, but I'm going to do 5 with substitution. 5 is lending itself to substitution because it's already solved for y. Like, it's literally saying, just throw me right there. Put me there, and everything is going to be great. And, you know, I've still got too many kids, like 20% of the juniors still can't do the distributive property. Like, I want you to figure this out, but those of you that hadn't figured out the distributive property, you're not trying, and you're probably not going to watch this video. Like, it's really sad. Like, you're going to fail. That's just the reality of it. 2 times 2x is 4x, 2 times 3 is 6, and then minus the x equals 12. Hopefully I didn't make a mistake on my rant. If I combine like terms, I'll have a 3x plus a 6, which is a 12. I'll subtract 6. 3x is 6. X is 2. Alright, so now that I know what x is, I can plug it right into there. And y would be 2, x is encountered, times 2 plus 3, which is 7. So my solution's at 2, 7, and it is going to be consistent and independent. If you have one unique solution, you are consistent, independent. 6 is an ACT style question, and this is kind of in your notes and it's kind of not, but they want this to have an infinite number of solutions. So what you're doing for is you're looking for a value of a that makes the lines the same. So I want you to think about this. This one here, if I shift my 2x over, is -y equals -2x plus 8. Divide out the negativity, it's 2x minus 8. If I shift the x's over, -3y is -6x plus 4a. And if I divide out that -3, 2x minus 4a over 3. To be inconsistent, the equations need to match, all right? So, to be inconsistent, the equations need to match because they need to be the same line drawn over itself. So you need to find a value of a that makes -4a over 3 equal that -8 right there. Of course, you also have to have this algebra done too. You don't just jump to this. This was important, and that's where I'm stopping on that one. Alright, moving forward, we got this one. We got a word problem. If I don't do it, I'll get asked. The local theater is showing an animated movie. They charge $5 per ticket for a child with $12 and $12 per ticket for an adult. They sell a total of 342 tickets and make a total of $25.50. Okay, so we'll just use descriptive variables here. You get $5 for a kid's or child's ticket. You get $12 for an adult ticket, and together, if you talk about the money side of it, you get $25.50. All right, what else we got here? They sell a total of 342 tickets. So if you take the number of child tickets, you add to it the number of adult tickets, you get 342 tickets. Now, okay, so 342 tickets were sold. That was the child plus the adult is 342. That we earned that much money, 5C plus 12A equals 25.50. And then we need to solve that system by the method of elimination. Okay, so what Milbrath is going to do, you do you, I'm going to do me, is I'm going to multiply that by a -5. That's going to give me -5C minus 5A equals -1610. I better get this right or Riley will correct me. -1710. 1500, 210. Yeah, I'm good with that. 5C plus 12A is 25.50. And then we're going to add down. And the C's are going to disappear. 12 minus 5 is going to be 7. That was supposed to be an A. So 7A. If we add down here, we got 290 there, 840. Seems right. 840, I'm good with that. Thankfully, that's divisible by 7, so I'm pretty sure I did my job right. 7 goes in 840 120 times. So there are 120 adult tickets sold. Okay? Now I can use the substitution property and put that right there. C plus 120 is 342. Subtract 120, and we will have 222 children tickets. So there was the work. We sold 120 adult tickets. We sold 222 children tickets using the elimination technique. And the last one I'm going to do is this one. Let me pause this real quick and take a look at the scale I want to do. I don't want to waste your time on this. Alright, so I think I'm going to do a 5 scale. Because these are 40 long, so this will take me all the way to 200 if I counted right. And that'll be enough. Alright, so the x value is stuck between 0 and 125. I'm going to do some counting here. So 125 divided by 5 is what, 25? It's going to put me right there. Now, I know these are hard for some kids to graph, but this is x less than 125, shade left. It's a vertical line. This would be x bigger than 0, shade right. Okay, so there's a constriction. This is called linear programming, by the way. I remembered what the word I was looking for. This is funny. Look at this thing. This says that 2y is less than or equal to x, or 2y is greater than 0. So let's divide by 2 here. Y is greater than 0 is one of them. That's the x-axis. And it's saying shade above me because I'm greater than. Shade up. This one's kind of funny. We divide out the 2. Y is less than or equal to x over 2. So that has a slope of 1/2, right? Think about your mx plus b. I keep saying this, but y'all are just not letting it stick. Quit being Teflon. Mx plus b. We rise 1, run 2. Rise 1, run 2. Because I left the x and y axis the same scale, 5 and 5, I can get away with this. I'm actually rising 5 and running 10. But whatevs. Alright, and that is going to be a less than or equal to symbol, so shade below. And then we have the last equation. We're going to divide the 2 out. x plus y less than or equal to 150. Make it look like mx plus b, negative x plus 150. And that's a less than or equal to symbol. All right. So I need to go up to 150. That's going to be 30 times 5. 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130. And then fall one, run one forever and ever and ever. Need lots of dots here or I'll miss it. It's easy to do. Believe it or not, it's actually ridiculously hard to draw a straight line. Let's choose a different color. Now, the symbolism on that one was less than or equal. So it's saying shade beneath me. So what all these things together are telling you is that this is your solution space. Anything in that shaded area is the solution to this graph, or the solution to that system of equations. Now there's no maximizing function here, so it's not true linear programming, but that is the solution of those inequalities. And that, boys and girls, is the time I have, because the bell has already rang and I want to go home. See you tomorrow.